Okay, welcome to our ICD webinar, monthly webinar. Today is our last session for this year, for 2020. We've been starting this program since June 2020, and today is the last session of the month. And maybe we meet again in next month in January for another two interesting talks. Okay, tonight we have a speaker from Indonesia, Dr. Ami, and also this session will be moderated by Dr. Monica Devi. Dr. Monica Devi is the treasurer of ICD Section 15. She controls the money of the association, so she got a lot of money with her. So I think today, what better than to have a counterpart from Indonesia also to moderate Dr. Ami. So Monica, I leave it up to you now to introduce the speaker and then carry on with the program. Monica, over to you.
Okay, thank you to Prof. Ibrahim for introduction and opportunity given to me. Good night and good wishes for all of you, our dentist colleagues that we respect. Welcome to Scientific Webinar Program of International College of Dentists, Section 15. This webinar is the last webinar event in 2020. We invite all of you to take a photo together by activating video as a memorial of the last webinar 2020. Please, Doctor. Thank you, Doctor. Okay, then we don't want to waste your time. Please let me to invite Dr. Ami Amelya from Indonesia to give the presentation with the title Digital Dentistry for CAD/CAM to 3D Printing. But before, I will read a short CV from Dr. Ami. She's graduated from the undergraduate program, Faculty of Dentistry, University of Indonesia, then continue the prosthodontic specialist postgraduate program in the same faculty of dentistry, University of Indonesia, and finally took the doctoral program in prosthodontic, College of Dentistry, Yonsei University, Seoul, South Korea. Since 2009, she was as a finance and IT manager at family-owned private hospital, Haja Karmin at Tasikmalaya. And then since 2010, she was a manager and practitioner prosthodontic specialist at Max Dental Center. And now she was too as a global trainer, educator, and consultant at Ostem Implant. Well, our beloved dentist colleagues, I don't want to waste the time. We can have Dr. Ami to give the presentation. Okay, Dr. Ami, please, you can start the presentation, please.
Okay, thank you for the introductions, Dr. Monica. And let me share my screen first. Okay, good evening, everyone. First of all, I would like to express my gratitude for this opportunity. It is such an honor for me, but I'm very delighted, but also nervous at the same time, because this is my first webinar. And I also would like to express my gratitude to the ICD Section 15 and to the President of ICD, Dr. Hao Kim Chuan, and the ICD Education's committee member, especially Professor Ibrahim. And I also would like to thank to all of my colleagues and also my friends who already support me and help me for preparations of this webinar, and also to all participants who joined this webinar today. It's already like 60 participants. I'm very grateful, and I hope this can be useful to all of you, and it's not making you boring or sleepy, because I will talk about a little bit too detailed, but this is just a brief introductions about the CAD/CAM and 3D printing is all about. And The topic for today, it will be about digital dentistry from CAD/CAM to 3D printing. So why I choose this topic is because the CAD/CAM and 3D printing in dentistry is, for me, I think it is very important and it can be very useful and have many beneficial and advantage if we use this system to the daily practice. And maybe some of you already familiar with the CAD/CAM and 3D printing, but for those who haven't familiar with the system, I hope that my presentations tonight can help you understand more about CAD/CAM and 3D printing. So I will start my presentations today. The two main topics that I will be talking is I will give presentations mainly on two topics. First is the CAD/CAM and the second part is the 3D printing. For the first part, for the CAD/CAM, CAD/CAM is short for computer-aided design and computer-aided machining. And we also know that more to be CAD/CAM means the subtractive manufacturing. Meanwhile, for the 3D printing, it is, we usually think that that one is for the additive manufacturing. And for the CAD/CAM, I will go back to history. So in dentistry, the major development of dental CAD/CAM system is occurred in 1980s. There is three pioneers who developed the CAD/CAM systems. First is Dr. Dure. In 1971, he began to fabricate a full anatomical crown using a series of systems. And he also developed the SOFA system. And the second one is Dr. Morman, which is a developer of the CEREC system. And he's focusing more into the chair side of the CAD/CAM system that you use in the dental clinic. And also he introduced the innovative same-day ceramic restorations. The third person is Dr. Andersons, the developer of the ProCera system. And in 1980s, he fabricated titanium copings by milling and spark erosions and introduced the CAD/CAM technology in the process of composite veneer restorations. And he also developed a processing center where he make a network of the satellite digitizer around the world. So he can scan from all over the world and then send the data to the processing center and then fabricate the all ceramic restorations. And what is the component for the CAD/CAM system? So the first one is a scanner. So either it can be intraoral or laboratory scanner. It's a tool for scan the data, the transform geometry into a digital data, and then can be processed by the computer. The second one is design software or CAD, where we design the restorations in the computer, and then we design it according to what type of restorations that we want to make, and then send the data to the computer-aided machining or the CAM or the milling machines. So the CAD/CAM productions concept, we can divide it into three. First is the chair-side productions, where all the CAD/CAM system is in the dental clinic. So from the scanning, designing, and to the milling, it's all in the clinic. And the second one is the laboratory productions, where the scanner, when the scanning is in the dental clinic, and designing and the productions is in the laboratory. And the third one is the centralized fabrications, where we scan and design in our clinic, and then we send the data to the fabrication center to fabricate the restorations. And for the CAD/CAM data sharing, we can divide into two. There's a closed system and open system. So the difference between this is for the closed system, we can only use the scanner and design software and the milling machine from the same manufacturer. But for the open system, we can use different scanner and software and also the milling machines. And For the scanner, as I mentioned you before, there is a laboratory scanner and intraoral scanner. So for the laboratory scanner, in general, we can divide the laboratory scanner into two. There is an optical scanner and mechanical scanner. So for the optical scanner, it uses projections of measuring light grid into the dental structures under a definite angle, causing a depth-dependent phase shift of the grid, which then the camera registers to its digital sensor. And then the structure will calculate the 3D data of the dental structures from the image received on the sensors. And the source of illuminations can be from white light, infrared, blue light, or LED or laser beam. And for the second type is the mechanical scanner. The mechanical scanner is where the master cast is read mechanically line by line using a Robbie ball, and then the 3D structures is measured. In this scanner, we have a high scanning accuracy, but the disadvantage is complicated mechanics, very expensive, long processing times compared to optical system. And the only example of this type of scanner is only Procera scanner from the Nobel Biocare. So the laboratory scanner, we will take impressions in the mouth and then porous a model, and then we will scan the model in the laboratory, and we use the laboratory scanner. These are the example of laboratory scanner, which is an optical scanner. There are several brands. And when you choose a laboratory scanner, you have to pay attention, like nowadays, they have like maybe how many megapixels. And for example, like this one, they have 4 camera of 5 megapixels, 4 camera, and you have to evaluate the accuracy of the scanner and the scanning speed, how long it takes for full R scan, or also if it's scanning and impressions, and if the scanner can also scan the color, and how many steps that scanner need for scanning the model. So this is some features that can be available. Depends on which manufacturer scanner. So this one is the example of CEREC INEOS X5. So instead of scanning the model, you can also scan the impression scan, and also scanning the triple trace scan, where you take impressions and you record the upper and lower and also the bite at the same times, and then you take this impression and then put it in the laboratory scanner and then scan it. And other than this, it also have the capability to multi-die scanning, where you can scan the die not only one at a time, but also like simultaneously more than one. And there's also features that can scan the texture. So when you do marking in the model, it can be scanned, and then you can use this guidance for when you're designing in the CAD software. And the wide operation range, how wide is the operation range is also important, because it has to be enough so that we can also put articulator, so we can scan the model while in the articulator. And for another scanner is the intraoral scanner. So intraoral scanner, we scan the data like the prepared tooth, adjacent teeth, antagonist teeth, and all the structures from in the patient's mouth. So it's called intraoral scanner. And in general, it can be divided into two: a single image camera and a video. So for a single image camera, it captures a series of overlapping individual image. So, and then the software can assemble these images into a large 3D virtual model. The example of this is the iTero, PlanScan, a CS3500, and Trios. And for the video camera, it's like a video recording, like record a video. So the example is the True Definition Scanner, the newest version of Lava Chairside, and Apollo DI and CEREC Omnicam. And for the intraoral scanner, based on the working principle, we can also divide into 4. triangulations, confocal image, active wavefront sampling, and stereophotogeometry. But I'm not gonna tell you into detail about the difference between these four, but I will only tell you about the triangulations and confocal imaging, because this is what we will discuss in later in this presentations. So the triangulations, you can see in the pictures, A picture. It is based on the principle that the positions of the point of a triangle can be calculated if we know the positions and the angle of the 2 points of the view. So it's called triangulations. And the second one is confocal imaging, where it is a technique based on acquisitions of focus and defocus image from selected depth. This one is the B picture. This one is the example of the CEREC intraoral system development. So earlier, CEREC BlueCam in 2009 used a confocal microscopy and triangulations using a blue light. And it is a single image capture with auto capture options, anti-shake, and needs powder before scanning the model or scanning the tooth. But later on, they developed a CEREC OmniCam with the video data acquisitions and more faster and precise full R scan, and also powder-free and can scan with color. And full R scan took about 8 to 12 minutes. And then later on, the newest version of CEREC, they have a CEREC Prime Scan, which released in 2019. It is a high accuracy smart pixel sensor dynamic depth scan. So they said that this intraoral scanner can have a better sensor to scan the part where it is deeper, up to 20 millimeters. And they make also like the new design of the scanner and also the acquisition unit and then they pay attention to the high level of hygiene because of the COVID pandemic situations nowadays. So it's more into the easier to clean, disinfect, and also sterilize. And also increase speed, and also powder free, and full R scan is only need about 2 to 3 minutes for this intraoral scanner. And this was another brand of intraoral scanner from Trios. So earlier, Trios 3 Basic is Trios using a confocal microscopy, and the first Trios 3 Basic use a cable, and the Trios 3, the later product, can make a wireless and additional patient feature applications. And the newest Trios 4, they add the additional features of caries detections, and also can record the patient-specific motions and monitoring. And there's a new patient's applications available, and also you can choose you want to with cable or wireless. So what is the accuracy of digital impressions if we compare to the conventional technique? Several previous research evaluate that the accuracy of full arc digital impressions was lower than that of silicon impressions, but it is better than polyether and irreversible hydrocolloid impression technique. However, another study found that digital impression technique were better than silicon impressions technique in the quadrant range. So there is a reduced accuracy of full arc digital impressions, and accuracy may differ, depends on the manufacturer of the intraoral scanner. So intraoral scanner have a better accuracy for the quadrant image instead of full arc scanning. I did a previous research several years ago, in 2014, and I investigated the difference marginal fit from all-ceramic crown fabricated using a direct intraoral scanner and indirect digital scanner. And in the first group, I scanned the prepared tooth in the patient's mouth, and I also took impressions, PVS impressions, and then fabricate a model and then scan this model in the extraoral scanner. And I fabricate the all ceramic crowns with the CAD/CAM system, and then the marginal fit was evaluated using a silicone replica and put in the microscope. So first of all, I scanned the patients with intraoral scanner and extraoral digital scanner. And I designed in the computer software and milling the all ceramic restorations. And I used the replica technique for measuring the marginal gap. So the result shows that all ceramic crown fabricated from impressions using a direct digital scanner, which is an intraoral scanner, were significantly more accurate than indirect digital scanner. But both groups is still within the acceptable limit of the required marginal gap for all ceramic crown, which is less than 120 micrometer. And these are several studies also investigated the difference between intraoral scanner and extraoral scanner in terms of marginal gap. You can see that several studies, this one from intraoral scanner and extraoral scanner of the for fixed dental prosthesis, and this one for restorations. In general, the intraoral scanner shows a smaller marginal gaps than extraoral scanner. Because the extraoral scanner, we don't just like directly scan, but we use the conventional impression technique and then pour the model and then scan with extraoral scanner. And this one is for the in vivo comparisons. Also, intraoral scanner shows smaller marginal gap. And another study from Brian and M, he investigated the trueness and precisions of 5 intraoral scanner for scanning edentalis compared to Dentate complete arc mandibular cast. So in a complete arc, the trueness, he found that trueness was less than 193 micrometers, and for a dentalis scan is less than 150 micrometers for Dentate scan. And for the short arc scan, less than 103 micrometers for a dentalis scan, and less than 56 micrometers for Dentate scan. So for intraoral camera, scanning in the short arc will show better trueness, and also in the model with the tooth also shows a better trueness or accuracy. And the complete arc scanning had low precisions, suggesting that intraoral scanning device is less reliable if we use for a complete arc scan, especially for edentalis patients. And he also measured that if the distance is 16 to 23 millimeters, it is still shows a good accuracy. He evaluated the 4 different intraoral scanner. So this is the research that I did. Me and my colleague and my professor did this about. We investigate the accuracy of intraoral digital impressions if we use artificial landmark. So because of the limitations of scanning the edentalis tooth using intraoral scanner, we try to design a model where we have a long span edentalis space, 26 millimeters, and then one model is without artificial landmark, and the other model we add artificial landmark. And we compare 3 different intraoral scanner, CEREC Omnicam, Trios, and CS 3500. And the result shows that there is improved trueness and precisions if we use the artificial landmark in the long edentalis area. So when we're considering about choosing the right intraoral scanner, we have to know the positive and negative features that intraoral scanner have. First, the first thing to know is the trueness, precision, and resolutions. The higher, the better. And the need for powder, mostly nowadays, new intraoral scanner don't need any powder. And the scanning speed, the faster is better. And if the tip is small and thin, then it is better. And we can be patient more comfortable, and we can position in the intraorally more comfortable and better view. And if the system is open, closed, or semi-closed, it's also important too. So these are some of the features for each scanner, intraoral scanner, that available. It is the system is open or closed. And like Trio's color, they have a color matching, so you can also check the color shade and what type of acquisition technology that it uses, and if they need a powder or not, and what type of imaging type. Is it video, recording a video, or is it multiple image? So what is the advantage and disadvantage of digital impressions? The advantage of digital impressions is that it's less patient discomfort, time efficient, simplified clinical procedure, and no more plaster casts, better communications with dental technicians, and better communications also with the patients. And the disadvantage is difficulty in detecting deep marginal lines of prepared tooth, but some intraoral scanner have also able to scan the deep part, and it is a new learning curve, so we have to learn and find out to get familiar with CAD/CAM system and 3D printing. And there's also increased cost when purchasing the machine and managing the machine. So the second component is the design software. For design software, it is a software we use in designing the virtual restorations in the virtual working cast, and then we compute the milling parameters. So we send the data to the milling. This design software, usually there is additional features or module options. So if you need this software to make implant prosthetic, surgical guide, orthodontic, or do small design, a smile design, removable dentures, or night guard or splint, you may have to purchase additional features that is not included in the standard features just for crown or fabrication of partial dentures. And the third component is CAM, which is a computer-aided machining. And there's actually two kinds, subtractive and additive, but additive, I will talk about this later in the 3D printing topic. So the CAM in this part is more into the milling machine. So what is a milling machine? It is a computerized milling device for manufacturing the restorations. It can be from solid block or disc into a restorative materials. And based on a number of axes, it can be classified into three axes and 4 axes and 5 axes. 3 axes have the X, Y, and Z axis. And for the 4 axis, there's additional rotatable tension bridge, which is an A axis. And for the 5 axis, there's additional B axis, which is the rotating of the milling spindle. So the 5 axis device enable the milling of the complex geometries, such as subsections. And for the milling machine, if it's based on a milling variant or milling process, it can be divided into 2. First is a dry processing, and second is the wet milling. For dry processing, mainly used for zirconium oxide blanks with low degree of pre-sintering. And the advantage of this is the minimal investment cost for the milling device, and also reduced time because no need initial drying times. And disadvantage is the lower degree of pre-sintering can result in the higher shrinkage of the zirconia. But some manufacturers also use the dry processing for milling the resin materials. And for wet milling, in this process, the milling diamond and carbide cutter is protected by a spray of color liquid to prevent overheating of the milled materials. And it is necessary for when you want to melt metals, glass ceramic materials, and zirconium oxide ceramics with high degree of pre-sintering. This is example of the milling machines that is compatible for Tri-scanner. Like Tri-scanner is open system, and although it can use with many different kind of milling machines, but this one is already like they have the trusted connections. So these are the selections, and when you choose this, you have to look for the how many axes the milling machine have. The more axes is better, and it's usually like this one for the chair side milling, so it can only do wet milling. This is one of the milling machines from OSTEM. They have two kinds. One mill 4 is 4 axis, and the other one is 5 axis. So this one is only can only do wet milling, and this one only dry milling. And this one can only use a block type of materials, and this one can do the disc type. So you have to know which material that you want to fabricate, and then choose the correct milling machines that you may need. Another milling machines from DENTISTRY Sirona. They have many kinds of milling machine. This one for the chair side one. This two type is for chair side, and this one can be chair side and for lab applications. The difference is only the capability of the block that they can use. So this one more bigger. That's why more restoration options that they can do, like bridge up to 4 units. This one can melt frameworks with up to 12 units or other kinds of restorations. And the more advanced one is also this type, the MCX5 from DENTISTRY. It's also a 5 axis, and this type of machine can do wet and also dry processing. So we can choose which one that we need. And it's also like can mill this type or block type. Another milling machine example, this one is from Plus Mill RS5. It's also a 5 axis. It can also mill dry and or wet milling, and can change, they have a changeable jig, block, and also disc. And this is an open system. So this one, there are several kinds of materials that they can melt. And this video shows milling a chrome cobalt framework. And this one, they use the pre-milled abutment to fabricate a custom abutment. So you have to, so this machine can do everything. You just have to change the jig and do the wet milling. And this one for the ceramic materials block milling. So you can melt simultaneously more than one block. Now I'd like to give some example and the steps that we need to fabricate the zirconia crown fabrications. And this video shows chair side zirconia fabrications from the CEREC system. First, we scan the side tube. After designing, we mill the zirconia crown. And then we use a sintering machine. So this video shows chairside one-day zirconia crown fabrications, but usually after the milling, the sintering step may took about overnight in the previous standard method. But this Cerex system, they introduced the fast one-day sintering speed. So after this, I will go into the 3D printing, which is additive manufacturing. So 3D printing is a generic term that describes the various method of constructing objects in a layer by layer manner. It has been widely used in several manufacturing applications in many areas. And its usability has resulted in a shift of focus in biomedical research and also in the dental field. And the birth of 3D printing has started from 1984 from Charles Hall, who invented the first stereolithographic printer. But only after year 2000 and onward, the 3D printing started to increasingly change the way in which the manufacturing was performed. There are several 3D printing techniques that can be applied in dentistry, and each technique differs in the manner which layers are built and also which printing materials that is used. According to American Society for Testing and Material Groups, additive manufacturing can be classified into seven processes. Fat polymerizations, where the process in which liquid for the polymers in fat is selectively cured by light activating polymerizations. And material extrusions. So because of the time limitations, I will only explain the one that we use more often in dentistry. So the first is the fat polymerizations, and second one is the material extrusions, where the process in which the materials is extruded through a nozzle or orifice. And there's also material jetting, where the process uses droplets of built materials are selectively deposited. So jetting is more into, it's like inkjet printer. If we classify it according to what type of materials that we use, for the light cured resin, we can use fat polymerizations or material jetting. The fat polymerizations, there are three. And this type of polymerizations is the most widely used in dentistry. So I will discuss about this in details today. And also briefly explain about the polyjet. And Another materials that we can use for 3D printing is thermoplastic, which using a material extrusions, and we call it fused depositions modeling, FDM, or fused filament fabrications technique. And there's also another materials, if it's made of powder, we use the powder binder, like binder jettings. And if it's a sinter powder, we use the powder bed fusions, which can be divided into selective laser sintering, selective laser melting. This one, we usually use this for metal materials, and electron beam melting. So the first one is stereolithography, or SLA. This is the world first 3D printing technology invented by Chuck Hull in 1986.
All 3D printing technologies create solid parts from 3D models layer by layer. Among them is SLA. SLA stands for stereolithography, a 3D printing process that uses a UV laser to cure liquid resin into hardened plastic. Upside down or inverted stereolithography is the most common SLA system. Depending on the machine, resin is either poured into a tank by a user or dispensed automatically from a cartridge. At the beginning of the print, a build platform is lowered into the resin, leaving only a thin layer of liquid in between the platform and the bottom of the tank. Galvanometers direct the UV laser through a transparent window at the bottom of the resin tank, drawing a cross-section of the 3D model and selectively hardening the material. The print is built in consecutive layers, each less than 100 microns thick. When a layer is complete, the part is peeled from the bottom of the tank, letting fresh resin flow beneath, and the platform is lowered once again. Originally developed in the 80s, SLA was confined to large industrial machines until recently. Today, desktop stereolithography offers affordable, high-res.
So for SLA, it uses a light-sensitive polymer cured layer by layer using a scanning laser. So this technique uses one laser beam to scan and build, cured one layer per layer. And the advantage of the system is rapid fabrications and also able to create complex shapes with high feature solutions, and can be lower costs if used in bulk. But the disadvantage, it may take longer time than the DLP. We will discuss this later. And because in SLA, we trace the layer cross sections using a point laser. And it's only available for use with light curable liquid polymer. And there's support materials that must be removed after the printing.
The Form 3B provides dental practices with reliable, affordable, chairside 3D printing of biocompatible products at a cost you can afford. From surgical guides to splints, models, dentures, and even aligners for simple cases, the Form 3B can streamline and modernize your digital dentistry workflow, leading to better and faster clinical outcomes.
We spent a lot of time thinking about how we can make working with the Form 3B intuitive and seamless, whether you're a dentist, orthodontist, lab manager, or technician.
Our Preform software integrates with existing imaging and CAD solutions and helps you prepare your part for printing and initiate the print job wirelessly. The Form 3B's mess-free, easy-to-use resin cartridge system, compatible with existing Form 2 resin cartridges, and the easily replaceable resin tank and build plate make changing materials and getting the printer ready to print a simple 3-step process. The Form 3B produces parts with unmatched surface quality and clarity. We fine-tuned our state-of-the-art new low-force stereolithography technology for optimal performance with biocompatible and other dental-specific materials. Smart sensors throughout the printer monitor print progress in real time and keep you informed and ready to promptly address potential issues. When the part is done printing, you can take it to the finishing station, where it will be washed in IPA, post-cured, and prepared for use. Light touch supports make removing support structures easy and leaves virtually no marks on the part's surface.
The Form Wash and Form Cure integrate perfectly with the Form 3B and make washing and curing printed parts a no-brainer.
Optimized settings for each material take the guesswork out of post-processing, leading to a streamlined end-to-end solution. From there, the part is ready for sterilization and use.
And whether you're new to dental 3D,
so these are the example of SLA materials that can be fabricated using the SLA 3D printing. And the second 3D printer type is the DLP, or digital light processing. In this 3D printer, they use a liquid resin, then cured layer by layer using a projectile light source, and the object is built upside down on an incrementally elevating platform. And similar to SLA, but the difference is in the DLP, it uses a digital light projector to flash a single image of each layer all at once. And because the projector is a digital screen, the image of each layer is composed of pixels, and it will become a voxels when it creates into a rectangular blocks. So it's a little different from SLA because this one is the, from the picture here, you can see it's an image. It's not one laser beam. And however, in DLP materials, usually the result can show rough lines because of the pixels. So it depends on the resolutions that the machine have. You can see directly if the 3D printer have good resolutions or not in the quality of the final product. And the light is projected into the resin using light emitting diodes or a UV light, and then directed to the build surface by using a digital micro mirror device. Example of the DLP 3D printer, Envision One from Envision Tech and OneJet from Ostem, Korea. And this is another example of digital DLP 3D printer, a D2 series from Phelps. So the advantage of this DLP 3D printer is that have a good accuracy and smooth surface and relatively fast. And DLP can achieve faster print times compared to SLA because the entire layer is exposed all at once. And it is also one of the lower cost technology. And disadvantage is it's only available for light curable liquid polymers and wax-like material for casting. And the support materials must also be removed. And another example of a DLP 3D printer is from Envision Tech, CDLM. CDLM is a type of continuous printing. So it can print the model more faster than the standard DLP printer.
From the originators of DLP printing comes the Envision One, a competitively priced, continuous desktop 3D printer from EnvisionTech. With enhanced CDLM technology and premium resins, the Envision One offers professional-grade results at the touch of your fingers. Its new domeless basement enables unprecedented speed, making it one of the fastest 3D printers available, delivering the most accurate models and robust end-use parts. Its expanded build platform enables high-volume output, allowing dentists to produce 10 dentures in under an hour, 6 orthodontic arches in 15 minutes, 18 quads with dies in 18 minutes, 6 castable partials in less than an hour, as well as indirect bonding trays and surgical guides. When speed and accuracy matters, choose Envision One.
And another type of example of DLP printer from EnvisionTech, this one have ultra high definitions. So the higher the resolutions is more accuracy. This is the example of the 3D printing materials that we already saw in the video. And another type of fat polymerizations is the mass stereolithography, or we call it MSLA or LCD. It's relatively new in 3D printing, and it uses a LED array as its light source and shining to UV light through LCD screen and displaying in a single layer slice as a mask. So there is additional mask that masking the light from below and then selectively shine the UV light to the materials. Like, just see the video.
MSLA technology consists of numerous individual light sources in a large array. On top of this array is a digital mask that controls which area of the build platform is illuminated at any given time. Wherever the digital mask permits light to pass through, the light will strike liquid resin, causing it to form a layer of a printed object. This way, MSLA technology allows for an entire layer to be formed in a single exposure, resulting in an extremely high throughput, regardless of the number of objects placed on the platform.
So this MSLA technique have advantage. It can achieve faster print if compared to SLA, because same like DLP, it's also built entire layer at once, and the price can be lower than the DLP because the low cost of LCD unit. So this type of 3D printer is more budget friendly. So this is the difference between the three, SLA, DLP, and LCD. SLA use a laser beam, and DLP use a projector cast as entire layer built at once, and the LCD also entire layer built at once, but there is an LCD screen mask at this part, so masking the projector lights. It's a difference. The benefit of using the LCD, DLP, or SLA 3D printer technology is that the ability to build the small and very detailed parts or object with fine complex geometry, diversity of 3D printable resin materials, and we can also get a smooth finish of the part produced. But the limitations for this 3D printing types is the post-processing is mandatory. You have to cleaning, post-curing, and resin removal. And it's also it requires time for cleaning in very smelly and toxic fumes, and the resin sometimes can be messy and it can cause skin sensitizations. There's a limited shelf life and fat life. It cannot be heat sterilized, and there's a safety precautions may be required when handling the materials. There's another types of 3D printer, which is fused depositions modeling, or FDM. This is the first 3D print technology mostly used in home printers. but the materials that can be fabricated with this type of machine is only thermoplastic, where the thermoplastic is extruded through a nozzle into the build platform. Usually, there's a very cheap, low or to mid-range cost of the materials and equipment. Just the daily basic 3D printer to this one is the more for dental FDM 3D printer.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers offer multiple finishing options to create smooth, even surface parts, including hand sanding, assembly, and cosmetic paint. Since FDM parts are constructed with production-grade thermoplastics, including ABS, polycarbonate, and Ultem, they are both functional and durable.
So this type of 3D printer is the cheapest 3D printer in the world, but it depends on you choose the low cost equipment or the mid-range equipment. So the accuracy is also different. And disadvantage is that it's only thermoplastic materials, and you have low accuracy if you buy the low cost equipment, and limited shape complexity for biologic materials, and the support materials must also be removed. Another type of 3D printer, which is a polyjet. It is using a light sensitive polymers, is jetted into a build platform from an inkjet type of printhead, and then cured layer by layer on an incrementally descending platform. So this printer is like an inkjet printer that we use for printing.
Polyjet is a layer additive manufacturing technology used to develop plastic prototypes from 3D CAD data. This rapid prototyping process uses inkjet technology combined with UV curable materials to quickly and economically produce highly detailed and accurate physical prototypes. Polyjet is one of the fastest prototyping processes available to develop high-precision physical parts and is ideal for smaller parts, appearance models, and master patterns. The Polyjet process begins by slicing CAD data into cross-sections or layers as thin as 6/10,000ths of an inch. The data is then transferred to the Polyjet machine, which begins constructing the object one layer at a time. Similar to how an inkjet printer lays down pigment, the Polyjet printhead deposits small amounts of ultraviolet curable material on the build platform, eventually forming a single cross-section of the part. An ultraviolet light attached to the printhead simultaneously cures the material as it is printed. Once a cross-section is complete, the build platform is lowered slightly to make room for the next layer. As the part is built, support material is added to give supplemental strength to fine structures and down-facing surfaces. After all of the layers have been created, the finished part is removed from the platform and cleaned. Although finishing is not necessary, a number of hand sanding and paint options are available.
So this type of 3D printer is relatively fast with high resolutions and high quality finish possible. And it's also materials available in various color and various physical property. And it's a lower cost technology. But disadvantage is that it cannot be heat sterilized and the materials can be high cost. So this is just a video explaining about when we use a 3D printer to make a digital denture. The printer used is the SLA 3D printer.
Hello, a few years now. We're excited that, and initially we're launching one shade of each, and we plan to have many shades of base and teeth released in the upcoming year. Denture Base LP is a denture base resin, and Denture Teeth A2 is a denture teeth resin. If you are looking for a detailed step-by-step guide, please refer to our 3D printed denture application guide. Formlabs Preform software will accept any open file type from Dental CAD software. We've been mainly using 3Shape here at Formlabs for digital dentures so far, but with any CAD software, it's really important to consider what tooth libraries are used and what output they will produce. In our testing so far, we've only found a few open teeth libraries, but there are also a few that are closed. The closed libraries only allow certain manufacturing methods. It's very important to test and try the dental CAD software that you will be using for digital dentures. That way you can discover which libraries are open and closed so you can fit it best to your dental business. In this section, we're going to go through the workflow and how to post-process and finish a 3D printed denture from the Form 2. We will be picking up right after the parts have been removed from the build plate and washed. We will be starting with removing the supports from the denture base and the denture teeth. To remove the supports, Bill's using his dental handpiece and a cutting disc to cut the supports and smooth them away. After the supports are removed, you'll notice that our teeth are splinted together, and we've found for the best aesthetic results, reduction of the interproximal connection will help make a more natural look. Combining the 3D printed base and teeth is easy. Once you remove the supports and washed your parts, take a small cup of denture base resin and wet the sockets with a brush. Place the teeth into the sockets starting from the posterior. Press the base and teeth together with one hand, and with the other hand, use a handheld UV cure light to tack the parts together. Continue repeating this process and move across the arch and forward until complete. You can also add denture-based resin to the interproximals or remove excess resin if needed. To finalize the connection of the teeth and base, the denture should be cured in a form cure. The denture should be placed into a 4-cup Pyrex container filled with glycerin and submerged. For 30 minutes, the denture should be cured in a form cure, then flipped over for an additional 30 minutes of curing, for 60 total minutes. During this final cure, the two parts become one. Once the denture is fully cured, simply polish it the same way you would a traditional denture. Using a rag wheel with pumice at low speeds will help it smooth the prints without flattening or removing characterization. Finally, using an acrylic high shine at high speeds yields a truly impressive result. Yeah, the process to combine the base and the teeth through luting is actually pretty easy.
It's definitely much easier than setting teeth by hand in wax and processing in the traditional manner.
We're very excited to see what everybody's thoughts and opinions are on this 3D printed product. If you start 3D printing dentures on your Form 2, send us some pictures. Our email is dental@formlabs.com. We'd love to see whatever.
Okay, so that is just a brief example of using the 3D printer for fabricating a digital denture, but there's several kinds of restorations that we can fabricate using a 3D printer, but I will only just give this as an example. So just a quick review on previous research about 3D printer. In this research, they investigate the precision and trueness of dental models manufactured with 3D printing technique with from four different 3D printer, SLA, DLP, FDM, and PolyJet. And the 3D printing technique shows significant difference in precision and trueness of each 3D printer. And for PolyJet and DLP technique is more precise than the FDM and SLA. And the PolyJet technique having the highest accuracy. This is a research from a colleague of mine, Im Changi, and this is about the assessment compatibility between various intraoral scanner and 3D printer. So it investigate which intraoral scanner is more compatible with which 3D printers. So in this research, they evaluate three types of 3D printer, SLA, DLP, and FDM, and with three different intraoral scanner and one extraoral scanner as a reference. And between these three intraoral scanner, the i500 from Medit is the most accurate, and the best combinations for the intraoral scanner and a 3D printer is the i500 and DLP printer. And for the SLA printer, it is also suitable to use with Trios 3 and i500. But for FDM printer, it is more suitable if you use the CS3600. So the mutual relations between intraoral scanner and 3D printer is varied depending on the combinations. Although no equipment could be classified as being most accurate, but the DLP printer was more accurate in the study, regardless which scanner that it was combined with. So for the conclusions, the CAD/CAM system consists of scanner, either it's intraoral scanner or extraoral scanner, and the CAD software where we design the software, where we design the restorations, and the manufacturing machines. Usually in the CAD/CAM system, it's more familiar with the milling machines, which is a subtractive manufacturing. And there is several CAD/CAM system that is available in the market, and each shows a different result in accuracy, performance, and features. There is an increase in use of 3D printing in dental field, and several types of 3D printer is available with different printing technology and printing materials. The most used 3D printer in dentistry, especially in dental clinic, usually is SLA or DLP for the light cure resin materials, and FDM for thermoplastic. And careful selections and considerations is needed to select which CAD/CAM system and the 3D printers that is best suited for your clinical needs. So thank you for staying with me until the end. I think I took like a little bit longer time. If you have any more questions, you can also contact me, or we will just put the questions in the chat box. Okay, thank you.
Okay, thank you very much, Dr. Ami, for your presentation. And now we are continuing with the question and answer session. We are opening the question session from the chat. Yeah. First, there is a question from Dr. Ishraf from Malaysia. I would like to ask a few questions. One, what is the minimum mode opening required for successful OmniScan to work? Is it suitable for patients with limited mode opening? Maybe you want to answer for this question first? Or continue with the...
I think it depends on, it's more about whether you can fit the intraoral tip inside the mouth. So if it can still fit there, and you can get a clear picture, clear field, then you can use it with OmniScan. But then if the mouth opening is very limited, maybe you cannot use this. So it is depends on which I cannot really exactly tell you how much like limited mouth opening for it to work. Like, but usually you have to a little bit like give some space for the scanning. But if it's too like if you scan like too away too far from the tooth structure, it's also not good. So maybe around 2 or 3 millimeters on top of the tooth structure. So after that, you have to consider the size of the OmniScan size. So if it still fit, then it's okay. Okay.
Okay. How long does it take to scan whole mouth? Is there a risk to repeat the scanning process?
It depends on which intraoral scanner that you use. From the fastest one, it can take about 2 to 3 minutes for the 1 hour, and longer, maybe longer than that, like maybe, but it's usually like less than 10 minutes. And the risk to repeat the scanning process, no, you can just, if you don't like the scanning, then you can just remove all, or you can just like delete some parts that you think is not good or like bad scanning, and then just repeat scanning in that area again. Like you don't have to repeat all of it. Like,
okay. And then there is another question from Dr. Selvia Purnamarika from Indonesia. What future benefits do CAD/CAM and 3D printing for dental practice, and which area of dental practice have benefit the most from 3D printing?
The benefit using CAD/CAM and 3D printing, of course, is the easy of use, faster, and it's also like some system offer the several kind of applications that is patient friendly. So we can, as a dentist, we can explain more details to the patients, and what will the restoration will look like in the 3D models, or in using a smile design, and which area that usually like of course, I'm a prosthodontist. I feel like a lot of benefit from this type of 3D CAD/CAM and 3D printing. But other than this, usually we also use this system for oral surgeon and for orthodontic. Nowadays, they make the splints, or you can also make night guard. And for the prosto, you can use like for fixed prosthodontics, the crown. Also conservative, maybe onlay, inlay, and there's like many kind of this can be useful. And also for the implant dentistries also can be used for the implant digital planning or virtual treatment plan. It's also using the CAD/CAM and 3D printing also.
Yeah, okay, thank you, Dr. Ami. Maybe Dr. Selvia Purnamarika from Indonesia, if you want to ask again, can write in the chat box, yeah. Okay, next the question from the Dr. Tisiva from Singapore. From your experience, if dentists would like to adopt 3D printing, what advice can you offer for consideration in process of system and range of clinical indication?
Usually the 3D printing that we use is the fat polymerizations, which materials of choice is made from resin, and it's kind of like SLA or DLP is a little like comparable, but nowadays there are more and more DLP 3D printer types available, and also the LCD type is also available, but it's more lower price, but the accuracy may be lower. So if you want to get like good accurate, maybe between DLP or SLA, I kind of recommend between those two. And then you have to consider like what type of, what kind of restorations or what type of like use in dentistry that you want to make, like spline or 3D surgical guide or like just a model. Like you have to consider that and then choose the correct 3D printer that can do that. Yeah.
Okay. Thank you, Dr. Tisipua. Have give a reaction. Thank you, Dr. Tisipua, for your reaction, and Dr. Ami for this answer for Dr. Tisipua. And then there's another question from Dr. Mariska from Indonesia. Is it possible to do digital wax up design with CAD software or 3D printing before mock-up creation?
Yes. You can design, you can take a scanner, scan of the intraoral, and then design, planning what type of the restorations that it will look like. And then you don't even have to print it. You can just show it to the patients, like the mock-up will be in the 3D like image. Or you can print it and then make it like wax, from wax, and then put it in the patients, or as a temporary. You can also melt and then place in the patients and then show to the patients. So there's several, like many different options that you can use with this technology.
Okay. Thank you. Maybe Dr. Mariska, if you have another question, you can ask again to Dr. Ami. And then next question from Dr. Antonius Irwan from Indonesia. Yes, how to sterilize the tip of scanner?
For the, like I mentioned, that there is a new scanner from CEREC, RemScan. Like they're focusing on the more hygiene concern. So they have the autoclavable tip. So you can use that if you want to like change that and then autoclave the tip. And then, but if you, there's also like several, like three kinds of tip. Like the other one is like you can just wipes with disinfectant, and the other one is you can like autoclave. So there's several kinds like that you can choose to sterilize the tip. Just follow the manufacturer instructions for other kind of like other brand.
Oh, okay. Okay, thank you for Dr. Ami for the answer for all questions. I think if anyone has any question, you can contact Dr. Ami directly, because I think for the time. Yeah. Thank you for all of you for your participation for the question and answer session. Thank you for Dr. Ami for the presentation and discussion at the session. And now I return the program to the Head of Education of ICD, Section 15, to Prof. Ibrahim. Thank you.
Thank you, Dr. Monica, for facilitating the sessions. And thank you, Dr. Ami, for sharing your experience to our fellow colleagues of ICD and also our members who have joined us tonight. And we hope that the presentation has give a good highlight or insight into CAD/CAM and 3D printing if you want to practice the current trend of 3D printing and CAD/CAM. So I think we have come to the end of this session. It's almost 2 hours for tonight. So again, on behalf of ICD Section 15, I'd like to thank Dr. Monica for facilitating the sessions and Dr. Ami for sharing their experience on her knowledge on 3D printing and of course CAD/CAM in dentistry. till we meet again next time. So I just want to share with you our next program. The next program will be in January 13. This time it's different. We're going to project some of the ICD humanitarian project. And the speaker will be Assistant Professor Dr. Tammy Duong from University of Hong Kong. So again, this will be on the 13th of January. Please make a note, 13th of January, same time, 9:30. And we hope that we're able to meet you again in slightly more than 2 weeks time from now. So we hope that Dr. Tammy will be able to share with us what other projects or human projects that ICD is carrying out in the region. Okay, till then we meet again, and of course, wish you all a Merry Christmas and Happy New Year, and have a great year ahead. Thank you and goodbye all. Thank you.